carry the 4, minus 14 cosine isn't... Oh, hello. I understand you want to learn a little bit about fractals. Well, follow me.
Professor Fern!
Oh, hello, Broccoli. Can I come too? Sure. Tally-ho! Well then, Broccoli, a fractal is an object that when shown at different scales reveals a shape that looks the same as the original image. So this original shape is actually made up of similar patterns. For example, look at this mountain range. Now let's look closer. And closer still. We can zoom in all the way to the tiny pebbles that rest on the ridge and it will still have that similar bumpy mountainous look. So you see, my student, this mountain is an example of a fractal.
Hey, Professor Fern, you kind of look like a fractal yourself. If I look at just one of your branches, it looks like your whole body. And then if I just look at one of the bits coming off, it looks the same.
That's right. I am a fractal. But I'm not the only talking fractal in this room.
Are you saying I'm a fractal too?
Why, yes, my young vegetable student, you are indeed. As fractals, we can be described as mathematical equations. In fact, this is true for lots of things we see in the world, like clouds, or even that CD you put in the microwave. How neat is that? Look at me, for example. I am made up by plugging 28 parameters into a computer calculation. Other ferns that look a little bit different from me are made up of a different set of 28 numbers.
Wow, you sure are complicated, Professor.
I am nowhere near the magnitude and brilliance of some other computer-generated fractal sets. Take the Mandelbrot set, for example. This fractal image is named after the mathematician Bernoulli Mandelbrot as he created it while working for IBM Computers. Here, let's take a look into this infinitely huge fractal.
Wow, look at all the colors.
The equation for this set can sum to extremely large numbers. So, what computer mathematicians do is set extremely large maximum values. The colors represent how many iterations it takes for the result to go over this large value, and the blackness shows small values that remain close to 0. And remember the mountaintop I showed you?
I sure do, Professor.
Well, with the mountain, we can only really see one repetition of the same pattern, meaning we could only zoom in once and see something similar. But with equations like those used in the Mandelbrot set, there's no limit to how many times we can zoom in and see similar patterns. That means we can zoom in further and further and never have to stop. Likewise in the opposite direction.
Gee, fractals sure seem interesting.
You know what fractals are really fun for? Dance parties!